I joined the Navy in 1972, and I thought I wanted to be a carpenter because I had never built anything with saw and hammer or anything like that. I was always doing work on mechanical things. So when I joined the Navy, I went into a division of the Navy called Seabees, which stands for Construction Battalion. And I went to boot camp in San Diego, and then I went to A school in Port Hueneme, California, and got out of that in the first part of 1973. My first duty station. Is that better?
Yeah, you don't have to be real close.
Okay.
That's just good.
Okay. And my first duty station was Adak, Alaska. I don't know if anybody knows anything about Adak, Alaska, but it's 1,200 miles out on the Aleutian chain from Kodiak. They call it the birthplace of the winds. And they call it that for a reason, because it blows all the time. It's cold, wet, nasty, snotty, bad weather all the time. The sun never comes out. So I was a California boy, you know, nice weather all year round and warm and oceans and beaches and whatnot. So I had about 30 days of this, and one day we had a muster. We had our master chief was giving out orders for the day, and they were looking for a volunteer for the machine shop. And I'd had all of this weather that I could handle, and I pushed about 5 guys out of the way and said, I'm your man. So I ended up in a machine shop in the Navy, which was a great experience because the Navy has some awesome machine shops. And for the rest of my tour in the Navy, I was in machine shops. I was welding, machining, fixing things, making things, repairing, and basically just keeping things running. Just like when I was a kid, fixing lawnmowers, and only on a grander scale. You know, a battleship is a little bit different than a lawnmower or a frigate or whatever. But anyhow, so I got out of the Navy, and I went to work in Northern California in a wetsuit factory, and got to know the owner of the company, and he and I were kind of on the same wavelength. He was an inventor, very smart guy. He was a very good welder and a great machinist, and a lot of that rubbed off. Wetsuit factories have a lot of sewing machines. They have clicker presses. They have clicker dies. They have a lot of machines that process this type of a rubber and turn this material into wetsuits. So I worked with that guy for about 2 years, and then I came out here to Colorado in the late 70s, and I went to work at a manufacturing company here in town and got to know the owner of that company, and he kind of took me under his wing. And he was an inventor also. He wasn't a machinist, he wasn't a welder, but he was a businessman, and he knew how to get products to market. He was a great salesman, a very smart guy too. He would come up with ideas, didn't know how to build it, and he'd come to me and said, Dan, I want to make this. And can you do that for me? And I said, well, yeah, tell me a little bit about what you wanted to do. And he would tell me, and we'd sit down and draw things out. And next thing you know, he'd have a product, and he said, okay, now build me a machine that'll make those 1,000 parts per hour. And I'm like, okay, I'll do my best. So that was a great experience working for him. So I worked for that guy for 7 years. And once again, he was more of a businessman. He was more into the marketing aspects, and he was great at it. He sold more of his product than anybody else in the country. And unfortunately, I didn't learn all of the marketing in the business, because that's turning out to be one of the hardest things I've ever had to do is sell a product to someone to convince them that they need to have this product that I've come up with. And so anyhow, after that, I went to work at an aerospace company here locally in town, and that was a whole different experience. Up until then, I made parts and I fixed machines to keep things going. So if I missed a tolerance by a little bit, I'd weld it up and get whatever needed to be running back running. But this aerospace machine shop was a whole different deal. These parts that we made had to be made to print, and they were very complex, and many times elaborate parts that had very complex geometries, sometimes close tolerances, and if they weren't made to print, the chances are really good that they wouldn't get sold. That would be called scrap. And if you generate enough scrap as an employee, you get fired or let go or given a broom and told that you're a janitor now. So, like I say, up until that point, basically all I was doing was keeping machines running, building machines, and just making things work. And if something wasn't exactly right, I would use JB Weld or Loctite and make it work and get the ball rolling, and that was how I operated. But on aerospace parts, it didn't work that way. You couldn't put JB Weld on an aerospace part and expect it to go up into outer space. So I learned a lot there. I learned a lot about precision work, and I learned a lot about how to think outside the box, how to create something before you even make your first cut in a material. So in that process, I learned how to do certain things that not guarantee good results, but help you get good results in your machining process. And part of that is, this is where I came up with an idea for an invention when I worked at that aerospace shop. I didn't pursue it at the time, but it was always in the back of my head. Does everybody know what a vertical turret mill is? Basically, it's a glorified drill press. It's a machine, it's a mill. It's a machine that has a spindle and a table. The table moves back and forth. The spindle can go up and down with a quill, and your tool rotates. It's like a router, basically. Only it works with metal and plastic and things like that. So in an aerospace shop, we make complex little parts that have geometry that's not always square with the world. So sometimes we have to tilt the head a little bit, and that's why they call it a turret mill, because you can tilt the head back and forth, forward and back. But once you're done doing that, you need to get that spindle perpendicular to the table so you can do accurate work. Now, when I say accurate work, I'm talking millionths of an inch, sometimes tenths of an inch, but sometimes millionths of an inch also. So to accomplish that, it's not a real easy thing to do. It can take anywhere from 15 minutes to an hour and a half. So I had the idea of putting a ring over a vise that was flat and parallel to the table. Let's say this is a vise, this is the ring, fits over the vise. You can dial in squareness on that ring. So that stayed in the back of my head. Didn't do anything with it at the time. But while I was working at that aerospace shop, I got a part-time job working for a guy that did subcontract manufacturing. In other words, he paid his employees for the work they produced. So he would get 60% of the job. In other words, if it was a $100 job, he would get $60, I would get $40. And there was only 3 of us working there at the time, so it was a small operation. And we, once I started seeing how things worked, I was kind of a hustler. I busted butt, and I would make more money than any of the guys in the shop. And I was making more at that shop than I was in the aerospace shop. So I said, you know what? Thanks, but no thanks on the aerospace work. I'm going to work down here. I'm making a lot more money. So I went to work for that guy full time. And he was getting up in years. He was kind of old and tired of the business and a little bit grouchy sometimes. And so one day, a guy came in off the streets wanting some parts machined. And he kind of had an idea of how much he wanted to pay to have these parts machined. And my boss looked at him and said, man, I'll tell you what, I'm not really interested. There's no money in it. See you later. Get out of here. Well, this guy, he was in a jam. He was in a real pickle, and he needed these parts machined. And I could tell that he was, he was going through some anxiety. And he kind of hung his head down and walked out the door, and I looked at my boss, and I said, you know what? I think I can make those parts, and we'll make money at it. And my boss said, yeah, but he needs his parts tomorrow morning at 10 o'clock. I said, no problem, I'll handle it. So I went back out in the streets, and the guy was halfway, he was almost to his car. And I said, you know what, come on in, I'll take care of it, you'll have your parts tomorrow morning at 10 o'clock. So I stayed late that night and ran the parts out and finished them up the next morning. And we didn't make a lot of money on it, we barely made shop rate, but the guy kept coming back with the same job. And I kept getting better and better and better at it, and within a month, I mean, he kept coming back every week, and within a short period of time, we were making a lot of money on this guy's job. And he pulled me aside one time and says, you know, Dan, if you ever start your own business, I'll be your first customer. That's all I needed to hear. So I started my own business. I had $3,000 saved up. I borrowed a little bit from my sister. I rented a couple of mills and bought a little lathe, and next thing you know, I'm making parts, working 20 hours a day and just kicking butt, And so that business I started in 1989, and it grew and grew and grew. And about 1994, this idea in the back of my head with this one device, because by now I'm doing all this close tolerance work, and I needed something like that because it's time consuming to do what I needed to do. So what I did was I mocked it up, just like this. I took a ring, I said, you know what, this is a vise, this is what I need. I need this over here, just like this. I took my tape measure, measured it out, got all my dimensions, figured out what would work and what wouldn't work, and I fabricated a prototype. And it worked. And it was simple. No moving parts. The only thing that was difficult about making a part was we had to hold flatness to 70 millionths of an inch, and we had to hold parallelism to 0.3 of a thousandth. So I worked on that and I got it. It took a while, it wasn't easy, but I got it. And so I took that fabricated unit around to 4 or 5 shops in town, people that I knew, and I said, what do you think of this? They looked at it and they said, what the hell is it? I said, well, it's a tram ring for squaring the head on a vertical turret mill. And they said, oh, and then the light went off, and they got it, and they were all interested. And I said, well, if I made some of these things, would you buy it? I said, damn right they would. And so the way to make them was not to fabricate. The way to make them was to cast them. So I made casting patterns myself, and we made up 3 different sizes. We made a large, a medium, and a small one, and we still make all 3 sizes. And so it was kind of a process. It took a couple of months to get from this point, from the fabricated unit, to having 50 of each of these castings in-house and then going on to machine these things. And do I know you? Gun guy? What's your name?
Jeremy.
Jeremy. Yeah, I think you were over in my shop the other day, weren't you?
Which one?
Acudine?
I think. What was it?
I was working on your gun.
On my what?
On your gun.
My
On
gun?
a 223?
No.
Oh, okay. Somebody looks just
I
like
was
you.
over in that area.
Yeah, okay. Sorry about that. Didn't mean to interrupt. You look real familiar. Where was I? Okay, so I did a patent search. It was a patentable product. It's a neat little deal. Everybody that saw it loved it. So I did a patent search. This was before the internet was going great guns, and so I went down to the Denver Library, did a patent search. I spent a day down there, and I did everything I could, and then I found a patent attorney, and we wrote up a patent and filed a patent. And the ball started rolling, and next thing you know, I've got all these parts that are ready for market. They were packaged, and packaging is kind of a big deal for something like this. I couldn't believe it, but it was, it was a big expense. And you'll see why in a minute. But so I wrote an ad, sent the ad out to 3 of the major trade publications. I wrote a press release. I sent out press releases to all the trade publications, got published in about 10 of them. And we were rolling. Orders were coming in. We sold, we sold probably 30 of these right here locally in town. And I would bet 95% of those shops that I sold to still have them, if they're still in business. And so anyhow, it was a popular tool. 2 weeks after the ads came out and after the press releases came out, I got a call from a guy in Detroit. And started talking about my product. He said, "Man, that's a pretty cool deal. Is it selling?" He said, and I told him, "Yeah, we're selling like gangbusters." He said, "That's great. I've got a patent on that thing." I'm like, "What?" And my heart just kind of fell out of my chest. And I'm like, "What are you talking about?" And he said, "Yeah, look it up. It's patent number such and such and so and so." And I said, "Oh my God." I couldn't believe it. So it turns out he was a pretty good guy, and we worked out a licensing agreement, and I paid him more than I wanted to pay, but not as much as he wanted. It was 7% of gross sales. So, and we made those things for about 4 years, and then the job shop end of my business was taking off, so I just kind of pushed it aside. I didn't want to keep paying him money, and I didn't have time for it. So,
Can I ask a question?
yes.
The guy in Michigan that had a patent on it, is that the one you filed a patent on?
That's the one that I filed a patent on.
So what happened to your patent pending?
I just abandoned it.
Oh, okay.
Yeah, he had it pretty well wrapped up.
Because I was going to say, it is a weird possibility. You can get a patent, but you're infringing. It's possible, not common. So, but that's just because the standards for patentability and infringement are different. But a lot of people, and we had this thing at the patent office Saturday seminar a few weeks ago, is that they think they get a patent and they're automatically clear of infringement. But that's not true.
Huh. Well, he had a patent on
So
something like that, but he had it wrapped up so tight, we couldn't beat him.
yeah.
So, and the only reason that he didn't make a commercial success out of it was because he was building it incorrectly. He had 4 legs, it was a fabrication, it was tiny, and it was overpriced, and nobody wanted it.
His business part was just going nowhere.
It was actually a bad design. It was a great patent, bad design, and it was overpriced, basically. So it was.
He was lucky he came along.
Yeah. So he was. So anyhow, that's how that thing got going. But this is what it ended up looking like. So this is what we make, and I don't want to pass it around, it's pretty heavy, but this is the surface that we hold flat to 70 millionths, and then between these 3 legs, we level that out to within 0.3 of a thousandth. And the guys love it, the machine shop guys love it, because when you tilt the head, when you tilt that spindle, say you're working on a vise here, and you need to make an angled cut or drill a hole at an angle, you need to bring that head back up and it's got to be perfectly square, or as perfectly square as you can get it without breaking a sweat. To do that, you've got to take the setup down, pull the vise off, and dial in directly over where your work is. Otherwise, if you move off, I'll tram in over here. You're skipping across T-slots on the table, and the table is sagging. That's just the nature of the beast on a vertical turret mill. So you dial it in over there, you move this back over here, and your head's not actually perfectly square. So our deal.
That sits on the table?
Pardon me?
That sits on the table?
This sits on the mill table. This goes over your work, sits right on the mill table, You got a nice, smooth, uninterrupted surface that you can put your dial indicator on, sweep that head in, and you're back in business in a matter of minutes, as opposed to half an hour, and then you gotta set back up, and it's just a pain in the butt. So
So that way you don't have to unmount your part.
you can leave your part right in. You can leave your part right in the vise, you don't have to take it out, which is actually a big deal sometimes, because some of these setups, you know, they get very elaborate, and it's just time consuming. So basically all it is the time saver, and it's a guarantee, not a guarantee, but it's more of an assurance of accuracy, if that makes sense.
Dan, are you still selling these?
Absolutely. Every day,
Good.
all over the world. Yeah. So that's that. So I sold that business in 1998. And it's now a major aerospace manufacturer here in town. They changed the name to Primus Metals. I don't know if anybody's heard of that company, but it's a very large company. We've got 150 guys working for them, and they're, I don't know, $20 million a year company. So it's grown, it's a big outfit. And in fact, I was talking with them today. They send us work and we send them work. So we're still on good terms, and they're doing great. So I retired for about 3 years, kind of goofed off for a while, golfed and fished and screwed around and worked on the house and watched the kids grow. That was one of the big reasons I sold that business, is because I didn't know how to get away from it. I had 3 young kids, a beautiful young wife, and I was just kind of running myself into the ground. Needed to change. Sold that business, and after I had a little side deal with an optics company, optical switching that I got into. I invented an optical switch. Totally different deal, doesn't pertain to this. But 2002, I started the business I have now, and I was going into this business with the assumption that I was going to do nothing but make product, and I wasn't going to do job shop work, because job shop work is so, it's a high pressure, high stress job. And so I started making these again. The patent had run out, didn't have to pay this guy Tom back in Detroit, I didn't have to pay his royalty, and I could devote all of my time and energy to making, manufacturing, and marketing this product. After about a year and a half, the writing was on the wall. I just was not selling enough of these, and it was probably due to my inexperience with marketing. And it goes back to what you were saying, marketing is so important. It is so important. You can have the best product in the world, but if nobody knows about it, you're not going to sell one. You know, people need to know about it. They need to know why why they need it. They need to know what the benefits are, and whether it's going to save them money, whether it's going to save them time, or whether it's going to save their life. You know, whatever it is, they need to know about it. So we still make these. I run ads in 2 minor publications, and word of mouth. We're selling, I don't know, I couldn't put an actual number to it. Sales on this, it's weird. You'll sell 20 one week, and then you'll go for 2 or 3 weeks and not sell one. It's just the way it is sometimes. It's weird. I can't explain it.
I have a question now.
Oh, go ahead.
So how many do you make?
We make them 100 at a time.
100 at a
Yeah,
time?
yeah. In fact, we're out of stock on the next size down on this, and we're waiting for our foundry in Oklahoma to get us more casting.
Okay.
The problem is they sent us the smallest casting, which we're overstocked on. And they actually screwed up the order. And so we buy them 100 at a time. So we'll buy 100 of these, 100 of the next size down, and 100 of the smallest one.
So now that the patent's expired, is there a problem with competitors coming in?
Nobody can hold the tolerances that we hold.
So that's your other advantage.
Right,
It's just
yeah.
the accuracy.
The accuracy of it, yeah.
And sometimes when you have a niche product,
It is a niche product, yeah.
it's not like everybody in the world
It's
can
not a
buy it.
Walmart product.
However, However, yeah, if you go onto our website and look at who's using the Easy Trim, all of your major research institutions, Lockheed Martin, all the branches of every service, anybody that's doing close tolerance work has one of these. And it's a pretty long list. And I'm not tooting my own horn, but it's a fact that people need this. And our biggest sales come from word of mouth, or from people that go from one business to another. They quit this job and go to work over here. Where's your Easy Trim? Easy what? You know? And so they take that with them. These things never come up in auction. If a machine shop goes out of business, somebody squirrels this thing away and it never gets sold. So, and we keep raising our price, and our sales don't diminish.
That's a great marketing.
Yeah, so
What are they selling for?
this one's $349. And we've got like, I think $52 in the casting, we've got $12 in the powder coating, we've got another $12 in a package, and maybe 60 cents in the caps, and another 50 cents in VOC paper. And so we're into them for about 75, 80 bucks. And we've got an hour's worth of machine work to make them. So at 75 bucks an hour, you're talking about 150 bucks to make them and 350 to sell them. So it's about right. If we were to go through distribution, it would be kind of tough, you know.
But this type of product works well direct.
It's product what?
I would say this type of a product works well selling it directly.
Selling direct, yes, yeah. Yeah, we just sell direct on this product. Other products is a different story. So, this little guy here, take a look at the big picture. I got a call from you know, when you're in this business, you go to trade shows, you meet people, and from all over the country, sometimes from all over the world. And I met this guy named Ron Posey from. He has a tooling supply business, and he's kind of an inventor also. He owns a company called Rovi Products, and he called me up after I'd met him at this trade show, and we kind of hit it off at the trade show because we were both inventors. And he said, Dan, I need a product that'll do this. And I said, okay, you want me to build it? And he said, yeah, you're a pretty smart guy. So this is what I ended up coming up with. Now, this is a work holding tool that expands from the inside, so you're holding on the inside of a part. Usually round, but it doesn't have to be round. You can machine this to whatever configuration you need to. The problem with what they had before, if you look at this is a tapered pin that's pushed into the center of this part, which is tapered also, and it expands that diameter. So what's out on the market now is there's a screw with a taper, so the taper is going the other direction. So if you turn that screw and it'll expand this diameter inside the part that you're holding on to. The problem is you have to have a hole in the part. If your part doesn't have a hole in it, that tool won't work. So I'm thinking, okay, well, we need to push from the inside. So how are we going to do that? So I came up with an idea for a can, for an eccentric. So basically, if you look at this, I didn't bring it out much with me, but if you turn this gold-looking thing here, you can see there's a cam there that pushes that tapered unit inside another taper on this diameter. And the hole's like a gorilla. I mean, it's just got a grip like you wouldn't believe. So,
So this,
So the guy sold a few of them, I sold a few of them, and when I said a few of them, it was 50 or 100. He sold 50 or 100. And we kind of lost interest. But I ran an ad, I ran press releases in all the major trade magazines, and within about 3 months, I got a call from a company back east called Money Bite. They had bought one of these tools and they loved it. And it was right up the alley of what they do. And so they approached me and said, you know what, we would like to sell your product. And I said, okay, talk to me. So they said, well, we've got a machine shop here. What do you think about us manufacturing, distributing, marketing, doing everything with this product, and we'll just send you a royalty check? I'm like, after everything I went through with this thing, I said, hell yeah, it's all yours, go for it, take it. And so we got a little agreement that probably wouldn't hold up in court, but they started making it and doing the marketing. They put it in with their family of products, which it just fit right into. And now I get a check every 3 months, and it's not enough to live on, but it's gradually getting bigger and bigger and bigger. So and I don't think it'll ever be enough for me to live on, but I'll tell you what, it's a heck of a lot easier. I could have done a lousy job of marketing, done a great job of manufacturing, and not come anywhere close to selling what these guys are selling. So I would consider that a success, and I don't have to do anything except take the check to the bank and pay taxes on it. So
You said that agreement won't hold up in court, so there's no contract, or is it just a verbal agreement?
no, it's a written agreement, and I actually didn't even get a patent on this thing. It is patentable. It is patentable. And there might be other applications for it other than what you're seeing there. However, the market is not big enough, and so we just didn't pursue it. Turns out these guys are great guys. They kept their word, but what they do, they do this with a lot of different people. So I said, well, give me a few phone numbers and names, and I'll call them up, and before I ever signed anything. And so I called every one of them, and they said, yeah, they're great guys. They do exactly what they say they're going to do, and I get my check every 3 months, and it's not enough to live on, but it's a nice little boost. So it worked out great. They're great people, and they were interested in my next product. So a couple of years ago, we've got CNC lathes, turning centers that can be made into semi-automatic machines with a tool called a bar puller. It can be done with a tool or with a machine accessory called a bar feeder. So basically, a lathe turns parts around. In other words, your part's turning like this here, and you take a tool and you cut it to whatever size you need. So that's a lathe. So when you get done with a part, usually it gets cut off, and then you need to advance that material so you can make another part. So there's many ways to do that, but there are only a few good ways to do it. One is a bar feeder that pushes the stock into the machine, and they start at about $10,000. And they have some drawbacks. They take up a lot of floor space, and they have to be tended every now and then. And there's maintenance on them. You can pull the work out by hand, which is very time consuming. You have to have an operator there doing that day in, day out. Or you can use a bar puller. Now, bar pullers have been around probably for 40 or 50 years, maybe even longer than that. And there's several different varieties. But the most common variety is a kind that has two fingers that comes down over the material and pulls the material out through the spindle. Let's say this is a piece that you're working on. So you cut your part off, and you take the bar puller, and it comes in here and grips on it with serrated pads, and you pull it out however far you need to pull it out, clamp onto it, pull the bar puller off and get it out of the way, and then you do your work. Cut it off, and then next thing, you do it again. The problem with most bar pullers is that not most, all but mine, is that you have to, when you go from this size to this size, you have to adjust the bar puller. Because your arm, your fingers are set for this size here, and they're spring loaded. And if you try to pull this, basically, you're not gonna touch it. Or if you set it for this, and you wanna go to this size, you gotta break the bar puller. So it's a big problem. It takes anywhere from 10 minutes to 20 minutes, sometimes a half an hour to make the adjustment. And it's $75 an hour, it's 15, 20, 30 bucks or more. And sometimes sometimes you'll have a whole tray full of chips down here and you'll lose one of your parts and drop it. And then you gotta dig through your chips. So you end up with a box full of parts, bent, broken, or whatever. So 2 years ago, I was thinking, man, there's gotta be a better way of doing this. And so I went back to the cardboard routine, and I didn't bring a sample for this, but I made up grippers, and I said, you know what, if we do this, I think I can make it work. So this is kind of what I came up with. I'll pass this around. So this guy mounts in the turret of the leg, and these things here. So basically, come on over here, I'll show you how this works. So you've got a hardened steel cup here. This is a urethane spring filling. Squeeze it. Turn your fingernail into it. That's a spring. Check it out. Isn't that amazing how stiff that is?
Like that, is that skateboard?
Yeah.
That, like a hard urethane?
That is.
Yeah. Yeah, really hard stuff.
Yeah, it's hard stuff. But you can compress that and it springs right back. It's much stronger
I
than.
can't compress it.
Well,
If you really push it, it gives just
Probably.
So the beauty of these things is they're way stronger than steel springs for their size. They don't shatter, they don't roll, they don't wear out. You can immerse them in coolant. They don't rust. They're chemical resistant. There's just a lot of things going for urethane over steel. There's a couple drawbacks, but for what we're doing, they're perfect. So it took a while. My first time out, it didn't work right. I was trying to use springs over here on this side, and hoping that the spring would push back over here. Didn't work so good. So I came up with the idea of putting springs right on top of this here. Basically, it's an eccentric. So as that thing moves, it pushes that up, and it compresses that spring. So basically, what you're seeing here is, now this is screwed down in there, but when it opens, the spring is compressed. So that's how that works. So let me show you when it's assembled. Now that was assembled. Try and spread those springs open, or those arms open. See? That's tough. Now you can go the other way, squeeze them together. So you get an idea of what's going on. Right. Try that. It is, huh?
But this will actually open going around a
Or
bar.
around bar, yeah.
Yeah, because you push it, right? So
Yeah, and you just push it right down into.
that is, so that would define your smallest size.
Right, absolutely.
Okay, and how far apart can they go?
That one will go up to 1 3/4 inches. We
That's a lot
advertise,
of range.
we
Yeah.
advertise 1 5/8 but it'll go up to 1 3/4.
So that, those, they open up, they pinch, you pull out,
Right, and
and
then
then
back
you
it off.
advance the work,
Yeah.
okay.
Yeah.
That is
That's a
heavy.
great idea.
So it works great, and once, we get them into companies that are like.
He's got a great video online showing how
Really?
you can use, yeah,
This is perfect.
and
And,
Accudyne.
and we just came out with that bigger one, it's great. And what happens is people buy one of them, and they'll have 10 lathes, and they'll run it for a couple of months, and they say, give me 7 more, you know? And they're not cheap, they're $600, you know?
Oh my God.
Yeah, so, it's
Because
pretty,
you machine like the whole housing and the.
everything, yeah. It's,
Oh
and it's all
my
through the
God.
steel, it's all hardened,
Yeah, so it's not a cheap thing to make.
yeah. Well, we've got about $150 a day.
Okay.
So, and we do sell some of these through distribution. And believe me, these distributors, they get a pretty penny for what they do. And some of them think they're really well. So,
Yeah, because I guess in the machine tool business, you wouldn't have retail, it would just be distributed
With MasterCard or something
to,
like that. Would be very good.
the MasterCard
to,
more of a, I don't know if they would sell something like this. Granger sells
Okay.
them.
Yeah.
MSC, American, Sid Tool, all of the tooling companies that sell to machine shops, Fastenal, big companies like that. So it's just now starting to get legs, and it's, you know, it's kind of getting things rolling, you know, we're selling quite a few of them overseas. And, it's a great little deal, it's good.
Wonderful.
Did you get a patent on that one?
I applied for a patent, we did our provisional a year ago this March,
Okay.
and did our full-blown patent application a year ago, March. 2 years ago, we did our provisional.
Okay.
And
So you guys
this
are
is last
pending,
year.
not
Yeah.
provisional.
So, anyhow, so it's going good.
I don't think you'd have any trouble patenting that.
No.
I don't think so either, you know, and
There's nothing else
it's,
like it, right?
pardon me?
There's nothing else like it out there.
Not that I have found. Once again, I did most of the patent search. So, so that's one thing I can't caution you enough on. You've got to do your homework on the patent search. My patent attorney looked at the search that I did, and I gave him all of the prior art and everything, and he said, it looks like you did a pretty good job. Do you want me to pursue this further? And I don't remember if I did or not, but anyhow, he says it looks pretty good. We haven't found anything else like it on the market. So, so that's that. That's basically my presentation. You know, when it comes to, if you have a product, if you have an idea that you want to have made, all I can tell you is the more work you do up front, as far as engineering, design, prototype, things like that, when you go to get your product made in a shop like mine, the most efficient way, the most cost-effective way is to have something that is as close to a finished product as you can see. Otherwise, you're going to get those pesky little charges when you make changes, and your bill is going to come out to be something you don't expect. I can give you a little example. When I was working for that guy that we did subcontract work for, he had a friend of his that invented a nutcracker. The guy was old and he had arthritis and he liked his walnuts, you know, and so he had this idea of a handle that you squeezed, and it would ratchet up this little vice jaw that closed further and further on this nut until it broke. And he wasn't an engineer, and he didn't know exactly what he wanted to have made or how it was going to look, but he had the ratchet part of it. And so we built him a prototype. He made changes. And it went from point A to point B to point C, D, E, F, and G, and by the time we were done, this was back in 1986 or 87, the guy had a $1,000 bill and a silly little nutcracker. And I said, well, why don't you just use a pair of vice grips, you know, or something. And the guy was not real happy that he had worked up a bill of $1,000 because he didn't have everything figured out beforehand. He let my boss do the figuring out for him. And it was a shock to the guy, and I kind of felt sorry for him. But, so the further along you have your product, and I don't know what Roger recommends as far as how you're gonna build your prototype, you know, if it's involved like whatever you would have in your motor system, you know, that sounds like a lot of work. You know, it probably is.
We got that question in the patent office, do you have to have a working prototype? Not legally, you used to in the 1800s, like, you had to make a miniature model of your invention and send it to the patent office, and they tested it. And then they had a whole basement full of them, and then they did away with them, but they're like valuable antiques now.
Hmm.
It's really cool, there's little steam engine things.
Yeah.
They're like tabletop, made from a craftsman, and they cost like 10, 15,000.
Yeah, no, I don't doubt it. But the thing is, you know, for me, I have to have something in my hand that works. You know, it's like this little guy right here. I couldn't just draw it up and take it to some machine shop and say, here, build me this, you know, and it'll work. You have to play with it. You have to make sure it's gonna work, just like you with your ladder thing. I'm sure you did all you,
Build mine out of 2x4s and
Yeah.
2x12s, and
yeah.
that sucker was
And then
really heavy to get up on the roof in the first place.
once you're sure it's gonna, once you're sure it's safe and that it's gonna work properly for you, you know, I would say, for me, I need to make sure people are gonna buy it. I mean, that's my next, because if they're not gonna buy it, why get a patent on it?
Right, I mean, it's
You know?
not a legal requirement, but it protects you, the inventor, to know what you're coming up with is plausible, works,
Yeah,
you know.
so,
So Dan, do you work in CAD at all?
absolutely, yeah, every day. Yeah, I've got 3 or 4 programmers, 4 or 5 actually, yeah.
So if someone has an idea, but they haven't worked it out, and they come to you to have a 3D
Model drawn up.
done,
That's not our forte. What I would recommend is getting an NDA and going to some high-grade student that's learning CAD, where you can pay them 15 or 20 bucks an hour, as opposed to 75 or 100 bucks an hour, and just work with them, you know, because they need the experience and the money, and you know, and you don't want to be spending a fortune trying to get something made that you're not exactly sure is going to get sold in the market. So once you're sure that you have a viable product, that you have people that are interested in buying your product, you know, then I would say go ahead, go forward with it. But until that time, I would say do everything as cost effectively as possible, because it can lead to some heartaches and some very deep holes in your wallet if you don't. It gets real expensive, you know.
Well, you're manufacturing oriented, but we do see inventors, I do, that they come up, it's just a concept, and they haven't proven it out whatsoever, and they wanna get a patent and want someone to run with it, and, that's just
doesn't happen.
pie in the sky,
Yeah.
It's like this urban legend that, I have this thing I kind of put together halfway, and then, and then
Yeah.
someone will send it.
Well, that's, you know, you always think it's the best thing since sliced bread, you know, but it's, what's important is, you know, is whether or not people can use it and use it for their benefit. You know, if there's no benefit in it, then nobody's gonna want it. So it has to be cost effective. If somebody, there are people out there that would pay $1,000 for something like that just because they can get it overnight, and they don't have to build it themselves. Not a lot of people, but there are people with those kind of deep pockets that will spend that much money on it. But for the majority of people that would use something like this, I think I'm still a little bit low on my price. I would like to raise the price again, and I may do that, just because I'm a little arrogant about it, you know. And, you know, I don't really need to make these things. The name is already out there. So if people want it, they can look it up on the internet and they can buy it. So You know, it's not a real easy part to make. Think of the tolerances we're trying to hold. 70 millionths flatness is that's less than 2 microns. It's about 1/30th or 1/40th the thickness of your hair. No, it's just not much. So we're holding these kind of, what's that?
10,000ths of an inch, oh, it would be if it's 72 millionths of an inch?
72 millionths.
Wow.
1 micron is 40 millionths.
Oh, point, it'd be 0.7 10,000ths.
Point zero, it would be 5 zeros.
Yeah, so it's not even a 10,000th, less than 1,000th.
Yeah.
I didn't think any machine.
Yeah, once you get down below a tenth of a thousandth, then you go into, a tenth of a thousandth is 100 millionths.
Yeah.
And we're at 70
Right,
millionths.
you're less than.
Right, yeah.
I didn't think a machine could be that accurate.
We lap those in on a 52-inch open face lapping machine. So that's how we get the flatness. And that's something you gotta kind of keep an eye on. You know, we're working with wavelengths, flatness, quarter of a wavelength on optical. So it's pretty flat.
Well, let's take a brief break, and then when we come back, and we'll open it up for questions. They can be related to something that Dan has